It's been a weird week. Like this morning, I bought some shoes from a drug dealer. I don't know what he laced them with, but I've been tripping all day. Sounds like a good time to start a new lesson. I like to pretend that you're a great listener who follows along closely to everything I say, but you keep posting cat videos on YouTube when you're supposed to be paying attention. Just this once, please, put the camera down and put Kat Benatar and Cindy Clawford outside for the next 10 minutes. If there's one lesson about RidePlayer you shouldn't miss, it's this one. Why? Because we're going to talk about synchronization, which is the holy grail of theme park attractions, and one of many things that makes RidePlayer truly special. Just as a refresher, earlier in this course we talked about the big picture of attraction design. Playing onboard audio is fantastic, but if it doesn't synchronize perfectly with the other systems in the attraction, it can turn what's supposed to be an exciting theme park moment into a comedy show. Let's talk a little theory. To explain with a simple example, imagine that you have two separate systems, one responsible for playing only audio and the other for playing only video. These separate video and audio clips are designed to play together. There's dialogue that matches mouth movements and sound effects that match action on the video screen. You get the idea. How do we ensure that these two systems start in perfect sync with one another? Let's consider the challenges. First, we have to make sure these two playback systems have a consistent playback latency. This is the time between when they are told to play and when they actually start playing. Unfortunately, many devices struggle with having a rock-solid reaction time, and as long as that's the case, there's no hope of consistently starting them in sync. Lucky for you, this is something we've been doing for 35 years, and we're pretty good at it. The next thing that bites us in the keister is network latency. With my example, it's going to take time for the commands to reach the audio and video systems, especially if a wireless network is involved, which is often the case with ride vehicles. Even with a perfectly consistent reaction time, network latency alone is enough to create a nasty offset in our video and audio playback. How do we solve this one? I've got it. Imagine that our audio and video systems both have atomic clocks, and both know exactly what time it is, down to the nanosecond. Rather than sending commands to start playback as soon as possible, we could choose to send commands to start playback at a specific time in the future. With the help of 1.21 gigawatts of power generated by a standard Mr. Fusion, both systems would accelerate to 85 miles per hour and travel to that precise time in the future, where they could then start playing based on that nanosecond accurate clock. Or, I guess they could just wait, though that's not nearly as cool. When he's not constantly breaking perfectly good electronics, Hunter is always looking for an excuse to put atomic clocks in our products. Unfortunately, the accountants got involved again. We decided it would be more practical to use other common industry methods like PTP, NTP, and GPS. This is exactly how Alcorn McBride products with SyncCore work. They're designed to share an extremely precise system clock using one of these methods, and then use the power of show control to schedule synchronous playback of media. SyncCore is also designed to accept these types of sync sources and perfectly synchronize the internal clocks of the product too. This includes the show control frame clock and the audio sample clocks. It really is the ultimate level of synchronization that you just won't find in any other system. Alright, enough theory. How do we actually set this up and make it work? I'm going to explain using the architecture that we recommend for most ride-based attractions. First, we recommend that the ride control system serve as the grand master for clock distribution using PTP. Chances are that it is already behaving this way anyway to keep the entire ride system in sync. So this is really just a matter of having our show control devices lock on to that same PTP master clock. At the moment, PTP doesn't survive well over wireless networks, which is unfortunate since many ride vehicles are connected using a wireless network. No biggie. The flexibility of SyncCore really comes in handy here and allows our V16X show controller to lock to a PTP source and redistribute the same clock as an NTP server. This makes things nice and simple for RidePlayer. All we have to do is configure its system clock to lock to the V16X. Here's how we do it. From our RidePlayer script, what we just need to do is go up to Configuration, Sync Timecode. And here we'll see where we can actually configure the RidePlayer's clock to lock to something else. All I have to do is click this drop-down and select NTP. Off to the right, there's a Settings button. I'll need to click that so that I can say the RidePlayer needs to sync to a certain IP address, which happens to belong to the V16X. Just like so. Once I push that configuration to my RidePlayer, it will start listening for NTP from the V16X master server. So let's go ahead and set up the V16X now. I'm just going to go ahead and create a new script for V16X. Also come up to Configuration, Sync Timecode. In this case, I'm going to lock the V16X to PTP. There really is no further setup required for PTP. There's lots of advanced settings, but generally PTP is a multicast animal, and it automatically picks up on a PTP master. So it will automatically pick up on that ride control system distributing PTP. I do have to tell it to redistribute NTP for the RidePlayers. That's done down here. All I have to do is click this checkbox and say that it's going to serve as an NTP server on port A. Okay, and I'm going to go ahead and push this to the V16. Now the V16 will lock onto that PTP source pretty quickly. It also won't take RidePlayer very long to lock onto the NTP source being provided by the V16. Once it does, we can view that status in the front panel menu. We can see that it's locked onto NTP, and we can even see the precision of that lock. Those yellow lock lights are always a beautiful sight. Alright, our system clocks are locked. What do we do with it now? Well, remember earlier when we talked about synchronizing sequences? And also remember how we created a sequence for each scene in our RidePlayer? All we have to do is create sequences for each scene in the V16X as well, assuming it's triggering things like projection that are designed to be synchronized with the ride vehicle. So I'm just going to go ahead and create a new sequence. Timeline, scene 1, projection, time sequence with timeline view. I'm going to go ahead and drag and drop a video clip onto this timeline. Drag it to 0. Like so. So now I have a timeline on my RidePlayer for scene 1 audio and a timeline on my V16 for scene 1 video projection. I flip back over to my RidePlayer script here. And again, I have a timeline for scene 1 for onboard audio and a timeline in the V16X for scene 1 projection. Within the RidePlayer, I'm going to trigger a sequence to start whenever the vehicle enters scene 1. I'm going to keep this simple for now, so let's pretend that the RidePlayer is hooked up to an input that will trigger it whenever the vehicle enters scene 1. I've also gone ahead and added the V16X as a device within the RidePlayer script so that they can communicate, because the RidePlayer is going to need to send a start sequence command to the V16X. Next, I'm going to create a sequence that will launch whenever that I/O point is triggered and we enter scene 1. I'm going to go ahead and assign it to that input scene 1. Within the sequence, I need to start my two timelines, both the onboard timeline and the offboard timeline. That's done using the start event. Timeline scene 1. And then the way I start the remote timeline is by name, start, and I do have to manually type in this name, so we're just going to make sure it matches exactly to what I entered on the V16X side. Timeline, scene 1, projection. Okay, that will start those two sequences. Then there's one other thing that's important. I need to make sure that both of these S checkboxes are checked. And what that does is it utilizes that sync system to schedule these events to actually happen at a point in the future. What is that point? That is a fantastic question. It's a calculation based on the current time with a consistent delay added to it. That delay can be configured here. By default, it's 16 frames. Just to demonstrate this in action, I'm now connected to both products, the RidePlayer and the V16X, and I'm running split screen here. So here's the V16X project, here's the RidePlayer project, and I'm viewing Scene 1 timeline for both. I'm going to go ahead and simulate that I/O trigger that I created just by clicking here and saying Start Sequence. Notice how both sequences start perfectly synchronously and how their clocks are running at the same exact time. That about wraps things up for this lesson. Once you get the hang of configuring the sync system and show control sequences, getting your RidePlayer to synchronize with other sync core based systems is a breeze. Now, go let those poor kitties back in, and I'll see you in the next lesson.